tutorial is on using synthetic division with polynomials. Before we get started with a few examples, let's check and make sure that we're all on the same page. In other words, that we all understand what we're doing. First, what we need to know is that we can only use synthetic division when the divisor of our is a linear expression with a leading coefficient of 1. Second, we only use the coefficients, but we must use a 0 or a placeholder of 0 for any missing terms in our polynomial. The polynomial must be in standard form before we extract the coefficients. In other words, before we put the coefficients into our synthetic division. We use the constant term of the divisor, but we have to change the sign. And finally, the quotient becomes the new polynomial. All exponents decrease by 1. I don't expect that you fully understand what this means yet, so let's take a look at an example. We have a polynomial x cubed plus 3x squared minus x minus 3, and we want to divide that polynomial by x minus 1. The first thing we need to do is know where our divisor is. So our divisor is this x minus 1. The next thing we ask, is this divisor a linear function or a linear expression with a leading coefficient of 1? And it is. It's linear because it's x. There's no exponent. So the exponent is 1. And there's no coefficient in front of the x. So we know that our coefficient is 1. So leading coefficient is 1, and it is linear, so we can use synthetic division. So what exactly does that mean? It means we rewrite our problem. We use only the coefficients, starting with the 1, the negative 1, in our x minus 1. We said to change the sign, so we use a 1. Next, we draw a symbol. It sort of looks like an upside down long division symbol. Next, we take out the coefficients of each term in our polynomial. So our x cubed term has a coefficient of 1. And our 3x squared term has a coefficient of 3. Notice I don't write the x's, the variables, and I'm not writing the plus sign in between. However, our x term has a coefficient of negative 1. So I do write the negative. And finally, our constant term is negative 3. In case you were unsure, let's check one more time. This is our x cubed term. This is our x squared term. This is our x term. And this is our constant. We don't have to write these variables and the constant above this. I'm doing that just to demonstrate. Next, we actually start the process of synthetic division. The first step is to drop that first coefficient, the 1. This is where it gets tricky, so please pay attention and use the pause button if you get confused. After dropping that first leading coefficient, we're going to multiply it by our divisor. So 1 times 1 is 1. And we write it under the second coefficient. And we add. 3 plus 1 is 4. We repeat the process. We multiply 4 times our divisor of 1, and we get 4. And we write it under the next coefficient. And then we add. Negative 1 plus 4 is 3. And we repeat again. 3 times our divisor, 1, is 3. And when we add, negative 3 plus 3 equals 0. Let's look at what this means. We said that this becomes our new polynomial, but all of our exponents change by 1. What exactly do we mean? We mean that we now have x squared and a positive 4x and a constant of 3. So this becomes our x squared term, our x term, our constant. So then what is this 0? That is our remainder. Now, you might wonder, how do we know for sure this is correct? And what does it mean again when we have a remainder of 0? Well, if you remember from the long division problem, when we have a remainder of 0, that means that our divisor, x minus 1, is a factor of our polynomial. It also means that our quotient, what we just found, is also a factor of our polynomial. So I want to check my work to be sure that I've done this correctly. So remember, when we check our work, we multiply. So we're going to multiply x minus 1 times x squared plus 4x plus 3. If you remember, when I multiply a trinomial times a binomial, I like to do it vertically. So I multiply negative 1 times 3 and get negative 3. And I multiply negative 1 times 4x and get negative 4x. And I multiply negative 1 times x squared and get negative x squared. Then I multiply x times 3 and get 3x, and that's positive. And x times 4x gives me a positive 4x squared, and x times x squared is x cubed. Now I combine my like terms, and I have x cubed, the cube, plus 3x squared minus x minus 3. And if we scroll back up, we'll see that that's what we started with. Let's take a look at another example. This example has x squared plus 3 divided by x minus 1. I want to know, is x minus 1 a factor of x squared plus 3? In order to use synthetic division, my divisor has to be linear and it has to have a leading coefficient of 1. X minus 1 is linear and it does have a leading coefficient of 1, so I can use synthetic division. That means that I'm going to divide, my divisor now will become 1, the opposite of negative 1. And I write my symbol, remember, an upside down long division symbol. And now I have to put my polynomial inside. I'm only using the coefficients. I notice that the coefficient of x squared is 1, so I write 1. And then I need the coefficient of x, but there is no x, so my coefficient is 0. Finally, I have my constant term, which is 3. Again, I have to have that x squared term, the x term, and the constant term. I don't have an x cubed term because there is no x cubed in my polynomial. Now I need to do my synthetic division. I drop my leading coefficient. I multiply by my divisor. I add to the next coefficient. I multiply by the divisor. And I add to the last coefficient. Now, I have no more to do. What do I know that I have now? I know that this becomes an x term, and this becomes a constant. So what is 4? It's the remainder. That means that if 4 is a remainder, x minus 1 is not a factor of x squared plus 3. Neither is x plus 1. So what do I have? I have that x squared plus 3 is equal to x minus 1 times x plus 1 plus a remainder of 4. I can check to see if I have the right answer. I drop my x squared plus 3. That's not changing. If I remember that x minus 1 times x plus 1 are conjugate pairs, they form the difference of two squares. So when I multiply them together, I get x squared minus 1. Then I have plus 4. When I simplify what I have on my right side, I have x squared minus 1 plus 4, which is plus 3. I do have the same thing on both sides of my equal sign, so I know that I found the correct solution. If you're still having trouble with synthetic division, I suggest rewinding and looking at this again. There will be many practice problems in class, and you can always look for other YouTube videos.